Okay, what happens to this vector if I apply the matrix? Doesn't change, right? Because anything in this direction isn't going to change. Doesn't change direction, and because lambda equals 1, it doesn't change length, right? Okay? So this vector stays the same, so I'm just going to draw it in red now. So we got this vector, right? Okay? Now what happens to this vector?
70% shorter.
Same direction, only 70% as long, right? So it was this long, now it's only going to be 70% of that. Okay? So what we can say is this one has the same direction, same length as this one, right? This one same direction. .7 times the length. Okay? Meaning that this vector here gets transformed to this vector. Now that's a picture that you should be familiar with, right? That's what happens. So if this is your 1,000, 0 vector, okay, this is going to be what? You're going to lose 10% of 1,000, you lose 100, right? And you're going to gain nothing. So it's going to be 900, 100. Okay? Still along the line as we talked about previously, so you might want to review your notes or review the videos on the pictures that we've drawn so far. Okay? But this explains it. If we do that to this vector, okay, well, it still projects to here. In other words, this vector is going to be the same, but now this one's going to get 70% as long, right? And then do it again, this one will get 70% as long as it was. Okay? So if you extend the picture, okay, you start with this vector, and you're going to have always this vector, okay? And you're initially going to have this vector, but then you're going to have a vector 70% as long as that, then 70% as long as that, then 70% as long as that. And if you keep doing 70%, what's going to happen? These are going to keep getting closer and closer together, right? So now you have the picture that you can draw by doing the matrix transformation. Okay? Same picture we've had. And if you start on this side, now this is, if this is 1,000, then this is 1,000 because this line is parallel to this one, right? And this line is where B is negative S. So it goes at 45 degrees, right? Rise is equal in magnitude to the run between any 2 points, but negative, okay? So all that goes together to tell you that this does lie along the line S plus D equals whatever, 1,000 in the case of our standard example, okay? So we put all that together with what we understand about straight lines, okay? So what we learned about matrices, and this picture here. And we see that, okay, well, same thing's going to happen. You're initially going to have this vector and this vector adding up to this, right? But now this vector is going to get 70% as long, then 70% of that, then 70% of that, 70% of that, 70% of that, right? So you see that you're going to have these vectors, and these vectors are going to represent your same dimensional populations at subsequent transformation, subsequent transitions, okay? And even more now, if you have some vector, like maybe you have this population vector here that isn't the same as any of these, you still have a pretty good estimate of where it's going to go, right? Okay? And of course, you can always do the 70% thing from there. Does that make sense? So there are all kinds of reasons this thing approaches a limit.
Okay, I get it, man.
Okay? You can do it with just simple algebra. Okay? Or we can raise it into the more sophisticated model with eigenvalues and eigenvectors. Okay? And now you have all the information to completely understand the whole model. Now there's still things you won't understand because there's a whole lot of machinery in linear algebra, okay? But I would be willing to bet you that the typical student at a typical decent university who completes a linear algebra class wouldn't be able to work this problem out. Okay? Wouldn't be able to develop this picture without a lot of hints. Okay? Now with right hints, you know, they could march right through it. But what I'm telling you is, this is a good chunk of knowledge here. Okay? And if you master it, you can really be proud of yourself. And if you just halfway understand most of it, you're still doing pretty well. Okay? But if you pull it all together, you know, you get to put a feather in your cap. That's kind of a big thing, right? If you walk around with a feather in your cap, everybody respects you. Isn't it? It used to be. Yeah, back in the 1600s. Okay, I guess that's no longer culturally. I can't even think of the adjective, but you know, it's no longer what you really want to do, right? You do something else. Dye your hair the right color. I don't know.